In this section today, which we're going to call 8.3 in Canvas, we're going to look at operations on functions and then more intensively, composition of functions. Now, it turns out that operations on functions, we can add functions, subtract functions, multiply functions, and divide functions, which sounds kind of complicated. And so when you look at it, you see that really we're just adding, subtracting, multiplying, and dividing monomials, polynomials. So we're relying on some skills that you've already got. Let's look at a couple of examples. Uh, we're going to call x squared minus 3x minus 4, f of x. And g of x will be x minus 4. And we're going to add those two together, f plus g of x, f times g of x, f minus g of x, and f divided by g of x. So let's take a look at what that would look like. So f plus g, I'm going to add these two together, x squared minus 3x minus 4 plus x minus 4. I'm combining like terms. X squared, I have a minus 3x and a plus x, that's minus 2x. A minus 4 and another minus 4, that's minus 8. So f plus g of x is x squared minus 2x minus 8. F minus g of x. So now we're going to subtract the two. X squared minus 3x minus 4, and then subtracting x minus 4. So remember what happens here is I'm going to change every sign in the second polynomial, and then change this sign. I'm going to add those. So x squared minus 3x minus 4. So distributing the negative now, minus x plus 4. So f minus g of x is going to be equal to x squared of a minus 3x minus x, so that's minus 4x, and then minus 4 plus 4. Those sum to 0. They're opposites. Let's multiply the two. X squared minus 3x minus 4 times x minus 4. X squared minus x, x to the third, minus 4x squared. So we're multiplying a binomial times a trinomial now. Negative 3x times x, that's negative 3x squared. Negative 3x times negative 4, positive 12x. Minus 4x plus 16. So let's simplify now. F times g of x is equal to x to the third. We're at a negative 4x squared and a minus 3x squared. So that's minus 7x squared plus 8x plus 16. And now to divide them. X squared minus 3x minus 4 over x minus 4. So one of the things that we're going to find a little bit later this semester is that we can identify common factors in the numerator and denominator even when we're dealing with polynomials. So I'm thinking to myself, can I factor x squared minus 3x minus 4? Two numbers that multiply together to make 4 and subtract to make 3. And I can see that that is x minus 4, x plus 1, and then over x minus 4. Now I have a common factor of x minus 4. So I can divide that out in the numerator and denominator. So f divided by g of x is just equal to x plus 1. Now let's look at the idea of composition of functions. And as this illustration suggests, we're thinking of functions again as a type of machine, but we're also thinking about inputs and outputs. And in composition of functions, the output of one function becomes the input of the next function. So let's take a look at what that might look like. F of g of 3. So this is saying that we're taking g of 3, so we're using 3 as the input for our g function, and then whatever value we get out of that is going to become our input for f. There's a couple different ways that you can think about that. One of those is that you can just go ahead and directly substitute in the 3 into the x minus 4, and then place that in place of the x squared minus 3x minus 4. The other is that you could go ahead and do your g of 3, which equals negative 1, and then use that as the input. So I had x squared, that's going to be negative 1 squared, minus 3 times negative 1 minus 4. So 1 plus 3 minus 4 is equal to 0. We're again working from the inside out. So f of 3, that output becomes our input for g. So f of 3 is 3 squared minus 3 times 3 minus 4. So that's 9 minus 4. That's negative 4. Now negative 4 becomes my input for the g function. Negative 4 minus 4 equals negative 8. G of f of 3, and then f of g of x. So let's take a look at what's going on with this. Here we're not given an input at all. I'll come back to this one momentarily. So we would take the g of x and substitute it completely in place of the f. So now I have x minus 4, and instead of x squared, my g function becomes the x. Minus 3 times x minus 4 minus 4. Here we compose the two functions, and then 3 is our input. So g of f. So x squared minus 3x minus 4 becomes our x. So 3 squared minus 3 times 3 minus 4, and then minus 4. Also results in a negative 8. So here's an opportunity to practice. We're given an f function, f of x equals x plus 7, a g function, g of x is x squared minus 4, and an h function, h of x equals negative 3x plus 1, and we're asked to find these. So you go ahead and work through those, come back and check your answers. So if you had an opportunity to check your work, f of g of 2. So we do g of 2, 2 squared minus 4. That's 4 minus 4 is 0. And now 0 becomes the input to our f function. 0 plus 7 is 7. So f of g of 2 is 7. G of h of 2. So h of x is negative 3x plus 1. So negative 6 plus 1 is negative 5. And then I'm going to take g of that output, g of negative 5. Well, g is x squared minus 4. So I'm going to do negative 5 squared, 25 minus 4, that's 21. G of h of 2 is equal to 21. When we have f of h of a number, that's more or less saying f of h of 4. So h of 4 gave us negative 11. Negative 11 plus 7, because that's the f function, gives us negative 4 for a value. And for D, f of 1. Is it possible to compose a function with itself? Absolutely. So we do f of 1 and find out that that's equal to 8, 1 plus 7. And then that becomes the input to our f function again. 8 plus 7 is 15. So f of 1 is 15. Moving on. Can we compose functions without an input value? Just putting the two functions together. And it turns out that yes. So f of x is x plus 7. We would substitute that in place of g. So g of x plus 7 squared minus 4. So this is x squared plus 14x plus 49 minus 4, x squared plus 14x plus 45. H of f of x. Well, f of x is x plus 7, so now we're going to put that into our h. H of x plus 7. Negative 3, x plus 7, plus 1. One last one. Go ahead and give 2g and then 3a and b a try and come back and we'll check your work. All right, so let's check your answers for 2g, which is h of g of x. So we take the g of x and put it into the h function, negative 3 times the quantity x squared minus 4 plus 1, with the distributive property negative 3x squared plus 12 plus 1, and that gives us negative 3x squared plus 13. So the composition symbol, that open circle, right, g composed of f of x. So now we're combining g of f. So we're taking the f function and inserting it into the g. Conversely, with part B, we'll take the g function and insert it into the f. And the order obviously matters. We're starting from the inside out. So this is what your work would look like for those two, and we have two very different results. G of f of x negative is positive 6x squared minus 2x plus 7. When we do f of g of x, we get 12x squared minus 14x plus 8. So that's the idea of composing functions. The basic thing to remember is you're taking the output of one, putting it into the input of another, and that can be done whether I have a value for that function or the function rule itself. Be sure to take some time, flip to the final page, and do your 3-2-1 summary, 3 things you learned today, 2 things you want to know more about, and 1 big question that you still have. Remember, there's a lot of space here at the bottom where you can make connections to previous classes, sketches, random thoughts, anything that helps you understand and summarize your thinking better.